Good afternoon, dear students. Hope you are doing good. As we are discussing this environmental engineering, we are in third unit right now. Hope you know, and we are discussing water quality standards. Water quality standards, that is IS 10500-2012 standards we are discussing as part of your curriculum. See, when we have a look in the past units, what we discussed so far, we have seen and we discussed protected water supply, objectives of protected water supply, role of environmental engineer, water demand, per capita demand, design period, and also factors influencing per capita demand, water demand. Likewise, we have seen all the basic preliminary information of this water resource, or as water supply engineering. Water supply engineering, in the sense, of course, this environmental engineering one in this curriculum exclusively deals the supply of water from the source to consumer. And in the meanwhile, what is exactly happening, we are going to discuss in this environmental engineering one. Dear students, see, in the second unit, we have seen what are all the different parts that are included, or as different stages that are included in this water supply. That means we have seen the sources of surface water, sources of groundwater, and also in the groundwater we have seen the different issues. Like springs, wells, and also we have seen infiltration galleries, so on. See, after that, we also discussed about the intakes and already given the brief synopsis or a brief scenario what we discussed in the past class itself. Now here in the third unit, so up to third unit, we are going to write in mid-examinations. See here, before that, we already entered in the third unit, of course, and we are discussing water quality standards. There are only 4 topics in this third unit when we made an attempt to divide the first unit. The first is water quality standards as per IS 10500-2012. And next one is comparison of water quality, or else, and also water quantity. See, when we hear the word the comparison, you may be remembered this is already discussed in the second unit itself. See here, but is again this is a repetitive topic which is included in the third unit also. See here, after population forecasting, when we entered into the second unit, this slide is already we discussed in second unit, but one more time we are going to discuss, as it is also included in third unit, comparison of water on its quality and quantity. Of course, comparison of water in all the terms, what it is exactly means. Before that, let us finish the topic what we already started. Small part of the previous topic is left over here, that is water quality standards. Up to here, that means general parameters. We have discussed this color, physical properties, color, order, pH value, taste, turbidity, total dissolved solids we discussed. See, this is the topic water quality standards, Indian standards 10500-2012. Here color has an units, requirement acceptability is 5 and permissible limit is 15. Order agreeable, pH value 6.5 to 8.5. And here permissible limit in the absence of alternative source is no relaxation here. The same wise, taste must be agreeable. There is no relaxation even the absence of reliable other alternative source. Turbidity, Nielsen turbidity units, that is here one requirement, and permissible is 5 when the alternative source is absent. Total dissolved solids milligrams per liter, 500 and 2000. You must remember the units everywhere. See here color, Hazen units, pH values, of course, turbidity next, NTU, and milligrams per liter for dissolved solids. Here general parameters, maybe you may call it as a chemical parameters. When we have a look over here, all the parameters, aluminum as Al, milligrams per liter, 0.03 is the requirement, acceptability. Permissible limit in the absence of alternate sources, 0.2. Ammonia as total ammonia, milligrams per liter, that is 0.5 and no relaxation. Anionic detergents as MBAs, milligrams per liter, 0.2 and 1. Barium as Ba, milligrams per liter, 0.7, and there is no relaxation in absence of alternative source. Boron as B, milligrams per liter, 0.5 and 1. Calcium as Ca, milligrams per liter for maximum, 75 milligrams per liter, and there 200 is the acceptable when the alternative source is absent. Chloramines as Cl2, chlorides as Cl, copper as Cu, fluorides as F, and requirement is requirement acceptability is 1, and absence of alternative source is 1.5. Likewise, free residual chlorine, milligrams per liter, iron as Fe, magnesium as Mg, manganese as Mn, mineral oil milligrams per liter, and nitrate as NO3, phenolic compounds as C6H5OH 0.01, and 0.02 is 0.002 is when the alternate source is absent. Selenium as Se, silver as Az, sulfate as SO4, sulfide as H2S, and the requirement acceptability 0.05, and there is no relaxation. See, when the absence of alternative source. See here, no relaxation. The same way, total alkalinity as calcium carbonates, milligrams per liter, 200 is the acceptable limit, and 600 is acceptability when the alternate source is absent. See here, and total hardness as CaCO3, zinc as Zn, and 5 is the required acceptability, and 15 is the acceptable limit when the alternate source is absent. Likewise, you must remember this table. See, these are the standards, and here the explanation part is you must remember what chemical and what is the requirement acceptability and what is the permissible limit when the during the absence of alternative source. You must remember this table, and the first one is physical parameters, and the second one is undesirable in existence, maybe general parameters, or else you may call it, if it is the physical, you may be called as chemical parameters. And the next one is bacteriological quality. Here, bacteriological quality has been divided into, namely, see here, 2 categories: treated water entering the distribution system. See here, one is water intended for drinking. See, what water intending for drinking, the first category, shall not be detectable in any 100 ml of sample. See, 100 ml of sample. See, bacteria should not be detectable. Should not be detectable when the water is intended for drinking. In the same way, when the water is when the water is entering into the distribution system, the E. coli shall not be detectable in any 100 ml of sample. Simply, the total coliform bacteria also shall not be detectable. That means the bacteria must be absent. And third category is treated water in the distribution system. The first one is for drinking, and the second one is entering. Third one is in distribution system, E. coli. Even the water entered into the distribution system also, it should not be detectable. 100 ml, and also the total coliform bacteria should not be detectable in 100 ml of seed. In one sense, any stage the bacteria should not allowed to be in the water. One is at the time of drinking, and another one when it is entering into the distribution system, and also in the distribution system, the E. coli and coliform bacteria shall not be detectable in any 100 ml of sample. Should not be detectable in the sense they should not be available in any 100 ml of sample. This is what about the bacteriological quality of drinking water. In the previous one, we have seen physical parameters. What we are discussing, water quality standards, IS 10500 2012. See here, physical parameters it is, and the second one is general parameters, and third one is bacteriological quality of drinking water. Understand? See here, next one is radioactive materials. Radioactive material in the sense, see here, see that this is also divided into two categories: alpha emitters. Alpha emitters, the requirement acceptability is 0.1, and when the absence of and during the absence of alternative source, there is no relaxation. And beta emitters, that is also requirement acceptable limit is 1, and there is no relaxation when the absence of alternative sources exists, and then during the absence of alternative source. So far we have discussed physical parameters, general parameters or any other chemical parameters, bacteriological parameters, radioactive materials, and next one is pesticide residues limited. Pesticide residues limited. See here, alachar here 20 micrograms per liter, and atrazine 2 micrograms per liter, aldrin or deldrin 0.03, alpha HCS 0.01 micrograms per liter, beta HCS 0.04 micrograms per liter, beta chlor 125 micrograms per liter, chlorpyrifos 30 milligrams per liter, delta HCS 0.04, 2,4 dichlorophenoxyestic acid 30 micrograms per liter, DDT, C, 1 micrograms per liter, endosulfan as alpha, beta, and ethion 0. Alpha, beta, endosulfan 0.4, ethion 3, gamma, C 2 micrograms per liter, isoproteran 9 micrograms per liter, malathion 190, methylparathion 0.3, monocrotophos 1, phorate 2. This is what about the pesticide residues limited. See, this is the fourth category. I mean, in water quality standards, the first one is physical parameters, second one is general parameters, or we can call them as chemical parameters, bacteriological parameters, radioactive materials, pesticides. You see, 1, 2, 3, 4, 5, all these you must remember, and you must write when you got a question, water quality standards IS 10500 2012. This is what the first topic in third unit. See, water quality standards IS 10500 2012. See here, the next topic is here, comparison on water, or comparison of water on its quality and quantity. See here, the surface water, the availability of water is always in two terms, or else in two types: surface water and groundwater. You know, the surface water is available in the form of lakes, rivers, oceans, and all. You know, see, groundwater, the exclusively water is available in the deeper grounds. We have seen the types of groundwater also there itself more elaborately in the name of wells, springs, infiltration galleries, all comes under groundwater. The surface water availability, surface water, the water that is available in the form of rivers, lakes, oceans is called as surface water. Now, how we can compare these two? How we can, in quality perspective, of groundwater is always good and potable than the surface water. Whereas in quantity perspective, surface water is more than the groundwater. See here, almost we have 97 or as 96, approximately 96 to 97% of water that is available in surface water in the name of oceans, whereas we have very little amount in the form of groundwater. See, if we are able to utilize the surface water for all the activities what we discussed in the second unit, I mean, the like 135 liters per day per capita we have discussed, for an average required quantity of water per capita, we have seen 135 liters per day. If we are able to utilize the surface water, there is no demand, or else there is no scarcity of water anywhere else. See, now the situation is we are unable to get the water even at certain metro cities, even at 1500 to 1600 feet, we are unable to get the water. If the surface water, we can convert them for utilization for daily purpose, daily consumption, there is no, we may not depend on groundwater. See, so many studies are going on utilization of surface water for all the activity. Of course, the river water, lake water, canal water we may be used, but the most of the water in the universe, it is in the form of seawater. Seawater in the sense salt water. If you are able to utilize the salt water at a more quantity, so the more quantity, we may not depend groundwater in the way we are depending right now. That means, of course, there are technologies are there and yet to flourish for large quantity of water to convert the salt water into fresh water. We have a technology, but if the technology comes to an existence in such a way, large quantity of water can be converted from the salt to fresh water, the pressure on the groundwater can be reduced. Nowadays, almost in all, metropolitans and almost all municipalities, the problem is with water. If the governments are able to supply water adequately, obviously the lifestyle will be the lifestyle or as the quality of life will be increased. See here ground, when we have a look over here, the water which is available in the deeper ground called as groundwater. See, the by nature surface water is soft. See, the next point is the surface water is tend to pollute rapidly because the human involvement is more and more. Almost the surface water is being contaminated, of course, with the involvement of human beings, and also because of the runoff. Because of the runoff that is reaching to the nearby catchments. You know what is runoff? The excessive amount of water that is flowing on from the surface water due to the saturated stage of a soil particle. What is runoff? The moving of water from the top of the soil due to the saturated stage of the soil particles into the where the water is moving into the nearby lake or canal. The moving of excessive amount of water from the top of the soil into the nearby river catchments during heavy rainfall because of the high saturated stage of soil particles is called as runoff. Once the water is moving into the nearby catchments from the top of the soil, obviously it will take some pollutants. It consists certain ingredients which may spoil the soil quality. That's what I mentioned there. Here the surface water is tended to pollute rapidly due to the addition of surface runoff, the activities of human beings, animals, etc. See here, next one is groundwater has less possibility of contamination because the water is directly we are taking water directly from the ground, because obviously the human involvement is less and sometimes the human involvement is absent. But the only possible way of contamination of groundwater is it may associate in the deeper ground itself, it may associate certain salt, silts, certain earthly materials. It may be contaminated certain point of times. See here, but comparatively the groundwater is good when compared to the surface water, and the level of pollution groundwater is less when compared with the surface water. See here, surface water can be used for consumption after the necessary treatment. See, the surface water can be used, that means after treatment only we can use this surface water, unless until we are not treating this surface water, the water is not supposed to be used for consumption. Whereas the groundwater we can use directly sometimes, as the chance of pollution is very less, and of course the treatment is sometimes needed when that depends on the state of soil. Most of the cases the surface water need treatment before consumption. Groundwater there might be a need of treatment before consumption. Not all the cases groundwater required treatment. Only certain cases groundwater required treatment for before that particular water is used for consumption. See here, one more thing is, even though surface water is available at high quantity, the usage is fully depends on methods that are adapted. The quantity of groundwater is minimum and its availability depends on methods that are adapted. See, I told you that the groundwater source is very limited, and nowadays the huge quantity of water is being lifted for to meet the demand of water. That is the reason almost most. And one more thing, why the groundwater is depleting year by year. The thing is, the huge amount of area is being converted into concrete, or else into a huge amount of soil is covering with tiles, or else with concrete, because of modern lifestyles. The percolation, the infiltration of water into the deeper ground is almost getting reduced, or is almost reduced because of the increased lifestyle. Almost most of the municipality urban areas, almost the topsoil is covering covering with concrete, and because and also for flow with flooring, where the infiltration of soil is not being absorbed. That is the reason the groundwater is depleted. The groundwater is moving downwards, moving downwards drastically, or at an alarm rate the water is moving downwards. That is the reason we are unable to get the water. That is the reason we are unable to recharge the water, because of the flooring of the soil. If the water is infiltrating, if the water is percolating into the soil continuously during the rainfall or during all the seasons of all the seasons, there is a chance of increasing water table. that is why that is why groundwater, when the lifestyle is increasing one style, the one side, and the groundwater is decreasing at another side. At one point, the comparison of surface water and groundwater, the quality prospective groundwater is good, and quantity prospective surface water is more. A quantity of surface water is more when compared with the groundwater. See, today we have discussed that IS water quality standards, IS 10500 2012, and also we have seen that comparison of water quality and its quantity. If you have any doubts, you please contact me through mail, message, or phone call, whichever feel you convenient. Thank you.